Okay, we're done with the second problem. Let's go to the third problem. Scalar ang work, ha? This is a really good example, by the way. A 30-kilogram crate is initially moving with a velocity that has magnitude 3.90 meters per second in a direction 37 degrees west of north. How much work must be done on the crate to change its velocity to 5.62 meters per second at a direction of 63.0 degrees south of east? So, ang tinatanong sa atin ay work. Okay? Sige, let's solve this problem. Maybe I'll be giving you a minute siguro to solve this. Sige. Okay, maybe 2 minutes have elapsed. Let's solve this problem. Ganito. First question. Okay. Let me remove that already. Hindi natin kailangan yan. So, ang importante ba sa atin yung directions? Yun yung tanong dito. Importante ba itong mga directions na to? Those phrases that I highlighted or I underlined. Are these important?
Oh.
No, these are not important. Therefore, you can remove them. Hindi natin kailangan yan. Sa formula ng work, what we only need is the magnitude of the velocity. That is the speed of the particle. Remember, work equals change in kinetic energy, which is 1/2 m v final squared minus 1/2 m v initial squared. Wala naman dyan ini-specify na direction. Ang importante lang ay yung magnitude ng velocity. That is the speed of the particle. Okay? Hence, these won't make, hindi natin kailangan yan. Okay? We don't need that. Thus, madali na to. Kasi ang gagawin lang natin, ang kailangan lang natin ay yung initial velocity at yung final velocity. At saka yung mass ng object. The mass is 30.0 kilograms. The initial velocity is 3.9 meters per second. And the, ito, kailangan natin. Ito hindi natin kailangan. Kailangan natin yung speed. And the final velocity is 5.62 meters per second. So this is just equal to 1/2 times 30.0 kilograms multiplied by final velocity squared, which is 5.62 meters per second quantity squared, minus the initial velocity, which is 3.9 meters per second quantity squared, and we get something like a work done, the total work done, for it to change its speed to 5.62 meters per second is 245 joules. That is the answer. Okay? Now the question is this. Sir, paano nagbago yung direction ng vector? Saan nanggagaling yung direction ng vector? Yung pagbabago dun sa direction ng force? Ay, dun sa direction ng motion ng object. Saan nanggagaling yun? Tingin niyo saan? Diba? Yung work, nagbibigay siya ng pagbabago sa speed. However, if you want to change the direction of an object, you need a perpendicular component of the force. Dito, ang kailangan lang natin dito ay parallel component. If you want to change the direction of an object, you need a perpendicular component of the force. Remember in your chapter, I think in the 2D and 3D chapter, remember, para magbago ang direction ng isang vector, kailangan yung acceleration vector ay perpendicular sa direction. In a similar way, you need, if you interpret it in terms of energies and other dynamical quantities, you need a perpendicular component. Yun yung dahilan para magbago yung direction ng object. Okay? Malinaw ba tayo doon? Kaya nagbago yung direction. Hindi yan due to work. It's due to another quantity, which we will discuss next time. Okay? Questions? May tanong ba?
None so far.
None. I hope this is clear. Okay? Just a conceptual idea, ang work hindi magbabago hindi nagpapabago ng direction yan. Ang binabago lang niya ay speed, not direction. It will change the velocity, but it will only change the speed of the object. It will only care about the speed of the object, not the direction of the velocity. Okay? Questions? May tanong?
None.
None. Okay.